We've gone through all the little weenie examples. We're going to move on to the big dogs here, and we're going to find out where we can actually use some of this trigonometry. Anytime you try to use trigonometry to help you figure something out, that is called solving right triangles. And and actually this is not going to be example 8, it's going to be example 9. Little typo there. Don't worry about it though. The angle you're given is called the angle of elevation, and I know you guys have talked about this in geometry when you're doing a little SOH CAH TOA action. Your angle of elevation represents the angle from the horizontal up to the object. The other angle you have is called the angle of depression. Angle of depression. Depression, that means what you're going to do is you're sad, you're lonely, you're looking down. So that's the angle from the horizontal down to the object. Okay, but it is always from the horizontal. That's what some people forget. You always measure these from the horizontal. From the horizontal. From the horizontal. So when we look at this example 9 here, we have some surveyor. It's saying 50 feet away from the base of a tree, a large tree. The surveyor measures the angle of elevation. That'd be from your horizontal up here. That's your angle of elevation as 71.5 degrees. We want to figure out how tall is this tree. Well, basically what you have is a nice, pretty right triangle. We're hoping that this tree has grown straight up into the air. You know, if it was off a little bit, then you can really use the SOH CAH TOA with right triangles. And so what you have is this triangle here. You have a right angle right here, and when you get a right angle, what you have is coming down here. You're trying to figure out y. So on your sides of your triangle, you are given your adjacent side. You are also given your opposite side. So we need to figure out from SOH CAH TOA which would we use if we were given our opposite and adjacent. Kenzie, what do you think? Use your sine, your cosine, your tangent.
Sine.
Why? Who? How? What would ever make you think that? We are all now just dumber for listening to you say sine.
I just picked the first one.
Just like your boogers. Well, you wouldn't use sine because that'd be your opposite and your hypotenuse. Here we're using our opposite and adjacent, so now you're down to cosine and tangent. What would you pick?
Tangent.
Ding, 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 ding. We're going to use the tangent of theta is equal to the opposite side over the adjacent side. And so what we do is we just plug these values in. So, once again, Kenzie, what do you think you plug in for your theta?
Why?
No stress. Where do you think your theta is? Would it be the y, the 50, or the 71.5?
The 50.
Yes, the 71.5 degrees. Because degrees is measured in theta or radians. Your opposite side would be your y, and your adjacent side is the 50. So in order to solve this equation for y, because we're trying to find the height of the tree, all you have to do is multiply both sides by 50. And when you do this, now you need to make sure that your calculator is in the proper degree. So if your calculator is not in the proper mode. So if we're talking about degrees here, do you think your Kinsey, what do you think? You think your calculator needs to be in degrees or radians?
Degrees.
1 for 3 ain't bad, folks. Degrees is correct. Degrees is correct. So let me make sure that my calculator is in the correct mode here. If not, I'm going to hate myself for doing all this hard work, making this pretty drawing, and not getting the answer right. Hey, cha-ching, we're in degrees. So what we're going to do is, if you saw this equation for y, you're going to get 50 tangent of 71 degrees is equal to y. So you just plug this into your calculator and you say 50 tangent 71.5 equals 149.4 feet. So the height of this tree is 149.4 feet. So Mackenzie, little background knowledge here on Uncle Kyle. Do you know, back when I was a toddler, about 3 or 4, I could scale a 150-foot tree in 3.5 seconds. You know why? You doubt it?
Yeah.
You know why though? We're all born from monkeys. So I was just a little bit more
Did you
original.
have more hair?
I did have more hair. Not on my back though. So anyway, thanks for your help. Mackenzie, this made this example a lot more enjoyable for everybody. I appreciate it.
Yep.
I think you're lying. All right, Klein and Kinsey, out.